commercial uses down in the future. So therefore, the amount of commercial lighting used that it was used, it's been reduced, because what happens? We use more and more and more lighting. This is why you see all this rebates with lighting. So if you study really what's the biggest consumption of energy use, is usually what? Motors and generators. If you look the overall, and then it becomes what? Lighting, so forth. So they are actually manufacturers who are working into these things. But there's tremendous amount of work, and it's done all in the European market and so forth. Because the Europeans are strictly full of what? Nuclear reactors up there. A lot of their energy comes from nuclear reactors up there. Any other questions for that? Any other questions? So there's only a portion of the spectrum that we use actually for the solar panels. Now, for every, of course, when you do the studies, for every wavelength, there's a certain amount of energy that you can get. So a lot of them, they're not going to look at the whole spectrum and say, oh, we're going to capture things, spend billions of dollars in doing so. And again, it has to be cost effective. Remember, the old times you had an MRI. An MRI, who could afford to take an MRI 20 years from now or 30 years from now? Because there was only what? Two places in two hospitals that had one. Maybe it was New York University and so forth. So you couldn't get an MRI then. So the people who were in the industry making MRI machines, what happens? They were going to make one or two a year because they cost what? Millions of dollars to make one. Now they have them what? In rolling carts up there. You can go to somebody's parking lot and get an MRI. Because what happens? The technology, people make them, insurance pay for it to get an MRI. So no matter what happens to you, you twist your finger, you get an MRI. Right? So that's what happens. Okay, so that's what I was saying before, that the solar radiation it includes more types of energy, just the visible light, okay? So usually the ones that we're using is actually goes from ultraviolet to infrared, and it's not actually evenly, okay? Now, as this amount of energy comes into the earth, you get what? Some of it is absorbed, some of them is scattered, okay, and some of them what? It's reflected. But a lot of the components in the atmosphere. So the atmosphere has what? Certain types of effects that has in the actually what? Solar radiation. So now when you look, for example, you said a cloudy day, well, what happens is that's going to be affected. So no matter how good your module is, now this thing is going to be affected. So then another thing, you have all the components in the atmosphere. You have ozone, carbon dioxide, water vapor, some other gases, particles, clouds, dust storms, air pollution, different kinds of volcanic eruptions, all will affect the solar radiation. We still get enough, okay? So by looking at that, you're going to find out that the amount that actually comes to the Earth is quite reduced. Now, what comes down in the Earth is two types. One is direct radiation, and the other one is what? Diffuse radiation. And we're going to see what the difference of the two of them is. Combined together, we get something we call global radiation. And when we look at practically, what do we see? We see the solar radiance. Some of them comes to the Earth unaffected. This is the atmosphere. Some of them diffused by the clouds, whatever particles we have up here. Some of it gets absorbed, never reaches the Earth. And some of them, it's sort of what? Bounces back. This is not good for this has nothing to do with the panel, unless it's actually reflected back. So this albedo radiation stuff doesn't do anything for the solar panels. So typically what do we have? We have diffuse radiation and direct radiation. Ideally, what do we like to have? We like to have a lot of what? Of our direct radiation into the atmosphere.
When radiation is a module, does the module absorb it or reflect it or both?
That's both. Some of it, depending on the glass, is reflects. But what you want to do is actually absorb it the most. That's an industry. There's a whole industry which actually they're working in the actually glass. Because that glass, not plastic, you want to make it plastic, you don't want to make glass, you don't want to crack, you want to step on it. What's the weight? You know, the initial modules, you can only step in the end. As much absorption as possible. Yes?
When you're selling a system, you have to advise the homeowner to check with their homeowner's insurance. Is there changing something on the structure of the house and protection of it? Say a tree, branch, or something damages it, hailstone?
I don't know, maybe some of you solar guys, you can answer that question better than I can in different of the things. The question was that when you install the solar panels up there, do you really go up there and check with your solar, with your insurance company? I mean, does insurance companies really insure solar systems? We must have some solar guys here.
Don't insure anything like furniture.
But the question is, you said before you install it, you tell the homeowner to check with the insurance company whether or not it's okay to install it, and they will insure it, so should there be any problem. I don't know how I don't know how the insurance companies, they treat that. Does they treat that as a personal property, a solar module, or as part of the roof? I don't know the answer to that, but I'll check. I have insurance guys. Yes. Yes. Each one of them. That's another discussion that we do. That's why when we go into the modules, when we go into the module description, each one of them has what? 48 pounds? It's a 48.4, 46, 40 something. There's a lot of weight. So actually, when we go into the mechanical mounting up there, if it's a flat roof, and you're going to install about 400 of them, that's a lot of weight. So you do need a structural analysis. That's why the gentleman up there, he said, you install a solar system, make sure that the roof is not going to collapse. So you need to have an engineer seal drawings. A lot of the stuff, for some of you guys, here's what you guys are going to do in the beginning. You're going to go see what we all do. How do we all do certain things? You're going to see one installed in a cathedral house, and you're going to say, gee, I see this one. The guy put 10 panels there. So you're going to go and do the same thing. Monkey said, monkey do. You know, we learn by what? By watching somebody else do it, okay? When we have a problem, then we pay our dues. And that's really how it happens, all right? That's really how it happens up there. For the people, of course, there are going to be people who say, listen, I'm going to invest myself $35,000, I'm going to have a job for $35,000. Is it worth it really to invest $1,000, $2,000 to have an engineering analysis done before I do so? Some people do it, some people don't. You guys are businessmen, you know what to do. Ideally, you need to calculate. When we go into actually designing a system like this, there's a lot of consideration that takes place. A lot of it. And that's why the test up there that you see that covers those things, that says you have to know about those things. Because you're not going to go put 250 panels in some roof when the roof is... Some of you, I don't know if any of you are in the air conditioning business, what happens when you go to put a rooftop unit in somebody's, 25-ton rooftop unit or a chiller or something. You don't go and just take the crane up there and say the guy just rested up there. Right? Same thing. Sometimes, excuse me? You have to provide the appropriate support to that, yes. Each module. So what do you think manufacturers look? To make modules what? Lighter as possible, lighter, stronger, and cheaper, and more power. More efficient. Wow. So, actually, the